In this tutorial, I'm going to go over using the chart and table pages to graph statistics and look at tables of statistics. What I'm going to do is start with this generic 5-band scenario, and I'm going to start iPerf3 on a server, and I'm going to start an iPerf3 client, just a simple client with these parameters. It'll establish a TCP connection and start sending packets between the client and server through KMAX. So while that's going on, we can see what's happening here. You can see that the packet gauge indicators have lit up, indicating that there's activity across the network. And there are limited statistics available for the interfaces. Up here it shows the number of bits per second received by the interface, and we can change the values here. Now, in addition, we can get more detailed values in the chart and table. If I click on the center icon, I go to the network graph page, and what I'm going to do is first create a filter in the classifier that is going to direct my iPerf3 packets to a dedicated band. And in this case, for iPerf3, is going to be using destination port 5201, and they're going to use TCP packets. I'm going to direct packets that match this filter to flow number 1, and I'm going to label that iPerf3. And as you can see, this packet indicator has lit up for the packets going to band number 1. Now what I'm going to do is, in the delay node for this band, I'll add some interesting settings. I'm going to go with 250 milliseconds of delay, and I'm going to add jitter. 50% of the packets will get a constant delay of say 10 milliseconds. And let me go ahead and enable the delay node. Now, because we're delaying packets by a quarter second, the input queue is going to fill up to a steady state level of about 42 packets or so. And down here we can see the steady state packet level in the bar graph. Now what I'm going to do to make things interesting is set the maximum queue length to 40, which means that packets will occasionally get dropped. And you can see the drop indicator flash every time the packets exceed the input queue maximum level. Now, with this going on, we can look at the chart and graph. And when we go to the table or graph, what you'll be able to do is look at statistics for the interfaces, the input and output interfaces here. And also statistics for the total flows for the input of a flow and the output of a flow, and also statistics for each of these individual nodes. So if we go down here and I click on the chart page comes up, and it automatically starts graphing statistics for the scenario that I was looking at. If you have a KMAX box capable of running multiple scenarios, you can select the scenario here in this drop-down. By default, the refresh rate is 1 second. And at 1 second, bear in mind that the graphs are able to show a total of about 600 sample points. So at a sample rate of 1 second, the graphs will be able to show a total span of about 10 minutes worth of data. I can increase the sample rate to say 1/4 of a second but then the total span that I will be able to see is less, in this case 3 minutes. Or if I want to run an overnight test, maybe I'll sample once every minute, in which case I'd be able to see up to about 8 hours of data. So if I switch back to 1 second, you'll see an indicator flash every time the browser goes out to fetch statistics. And you can start and stop the statistics with this button. Now, each of these main graph boxes can graph 2 parameters in an orange color and a blue color. So up here, this top section would be our first waveform in orange. You can select from one of the flows. You can either select one of the interfaces, or you can select one of the chains of impairments, one of the flows within the network graph. And so, for instance, iPerf3 was the name of our flow that we have the delay node turned on. So if I select that, I can then select various parameters for that chain. There are various impairments such as the rate limiter drop node, that sort of thing. For instance, I could graph the number of packets dropped in orange. And this is the total number of bits. To make it a little bit more sensical, I could graph total packets. So we've had, up to this point, 55 packets dropped in that delay node. And so for the second waveform, I can graph, say, the default flow. This would be a traffic that was not matched by the filter and not forwarded to my iPerf3 flow. And so perhaps I could graph total packets again. Now, if I select a flow input or output, then you'll be able to see a volume meter. And it's similar to the volume meters that you see in the statistics box at the upper right-hand corner. And I can click to change the units to bits per second or packets per second. Once you have a graph going, you can then use these 2 subgraphs to zoom in. The graph at the bottom is called the master zoom graph, and I can use that to zoom in to the detail graph, which is at the top. Now, if I zoom in and then position my zoom window to the far right, this little anchor icon turns on. And what that means is that my zoom window will remain stuck to the right-hand side, so that any incoming data will come into the detail graph and then scroll to the left. If I instead move it off the right-hand side, then my little zoom window will track with the data that comes in. So the data that you see will be static. It won't be constantly scrolling to the left. It is also possible to make a selection by dragging the mouse, or by clicking once to clear the selection. Now, oftentimes, if you're looking at data that has a large dynamic range, sometimes it's better to look at a graph that has a y-axis in a logarithmic progression. So I can go in here and set my axes to be logarithmic. In addition, if I'm in linear mode, then I can either use auto zoom or full scale. If I switch to full scale, then the graphs will start with y equals 0 for the bottom y number. But in this case, you might not see subtle variations, such as with this blue graph here. If I go back to auto zoom, it more clearly shows me just the variations in the graph, so it's easier to see the ups and downs. In addition, if both waveforms have the same units, here I have total packets and total packets, I can click on Use Same Y-Axis, And what this will do is it will use the same normalized y-axis on each side. So we have 0 to 7.2 megapackets. And so it's easier to compare the two waveforms using the same y-axis. Also, if I'm looking at units of total count, like total bits or total bytes or total packets, I can reset the count by pressing 0 counts. And as you can see here, the counts have reset to 0 and then will continue to grow over time. I can press this button at any time to reset the counts. And then when the counts are in a reset state, I can press this Restore Counts button to go back to the actual absolute values. Now it is possible to add more graphs. Each one of these graph boxes contains 2 waveforms. For each one you can give it a custom name. If I scroll down here, I can say Add Chart to add a second graph, such as the RE0 interface. I'll look at the received data and I'll look at the packets per second, and maybe something similar to the RE1 interface. Maybe send data, total bits. Now if I select a flow that will definitely not have packets going to it, then you get this red icon. And hovering over the red icon, it tells you what's wrong. And in this case, there are no filters in the classifier that will forward packets to this flow. So you'll never see any data going through this flow. That's why it's alerted you to that fact. But if we go back to looking at the RE1, say total bits. Okay, now that I have my 2 graphs, and say this is the interface, I can now reorder the graphs. I can just press Shift up and this graph will go up and it will be replaced with the graph that was previously there. I can also press Delete to delete that graph down here and Restart to restart the graphs. Now that does it for the chart. If I go over to the table by clicking this button, it's a similar setup. I can give it a custom table name. And in this case you see many parameters all at once in a table format with, once again, a flow-related inputs and outputs, or on the interface, send and receive statistics are shown with the volume meter, and once again you can switch between packets per second or bits per second. And similarly with the chart, you can select the flow or interface, and then once you've selected that, you can then see the various parameters in real time. And let's take a look at our iPerf3 flow, because down here it will show the statistics such as the number of packets I currently have queued and the number it's dropped due to overflowing the input queue, the number of packets that have been delayed. I can select a unit and for instance say bits per second, and then you have a choice of fixed or auto. In the fixed sense, you see absolute values for the readout, and there's no simplification or addition of units suffix, but sometimes it's easier to read if you switch it to auto, in which case you'll always get a suffix such as kilobits per second, and the values will be shown with 2 digits of precision after the decimal point. So sometimes it's easier to read this way. Sometimes it's easier to read fixed with no simplification or truncation. Similarly, I can add a second table, add a second table name, and then select more flows, or delete the second table. Now when I make any configuration changes either on the chart or the table, such as these drop downs, My configuration is stored in the local web browser in the form of cookies. It's actually called local storage. So if I were to relaunch this table using the same web browser, I would come up with the same configuration. So your configuration is saved between times that you invoke the table or chart. And that pretty much does it for this tutorial.